Unit 2, Lines and Angles, Lesson 2.1, Graphing of Lines. Don't forget the date, time, and location, as well as a parent sign-off. Please don't try to multitask while you're doing this video. Before we get started, without a calculator, I'd like you to fill out this page as fast as you can. Ready? Go! Let's see how you did. The main thing that we are checking here is the fact that any radical times itself is just the number on the inside. So that's root 4, so that's going to be 2. That's 5, 3, 7. That's going to be 5 times 2, 10, 30. That's 5 times 4, that's 20. That's 3, so that's 24. Here, that's just another root 6, and this would be root 5. If you got that correct, big star. If you got it wrong, make note of what you got wrong. Today we're going to probably be reviewing something that you have seen before, which is the graphing of lines. We're going to move kind of quick, assuming that you've seen this before. So in graphing of lines, the key terms include something called rate, slope, Y-intercept, X-intercept, Slope-Intercept equation of a line, point slope. You're going to need a straight edge, of course a pencil, and a red pen to correct with. It's important that when we're graphing lines, we're not just graphing a physical thing. Line graphs are predictive formulas. They're data points, and we create predictive formulas into corresponding graphs. The most important aspect of graphs is understanding the concept of slope. Slope is rise, the amount of up and down over run. So come over here on the right, just kind of trace your pen along the slope. The slope right there is going to be the rise, just straight up and down over the run. Rise over run. We'll be coming back to the equation for slope in just a moment, but when I ask you for slope, the definition of slope, what I'm asking you to give back to me is rise over run. Now we read graphs from left to right. So reading from left to right, if the line is going upwards, that's a positive slope. Reading from left to right, if it's going downwards, that's a negative slope. Now remember rise over run. So when a line is horizontal, it has no rise. It has no up and down motion. So that's going to be a 0 over whatever that run number is. 0 over anything is just 0. When you have a vertical line, your rise is going to be a number, and your run, the left to right, is 0. But you cannot divide by 0. Whenever there's a 0 in the denominator, it ends up being undefined, also known as no slope. Very important. 0 slope and no slope are not the same thing. They're not interchangeable. We use the term no slope for undefined. Couple other terms you need to be familiar with is what's called in a line the Y-intercept and the X-intercept. The Y-intercept is where the line crosses the Y-axis. So in this red line, let's mark where the Y-intercept would be. That would be the Y Y-intercept. Go ahead and let's graph the coordinates. Our x-coordinate is 0, and our y-coordinate there would be -3. So in this line right here, the y-intercept of that line is -0, 3. 0, -3. The x-intercept is where the line crosses the x-axis. Put a dot there. And now let's do the coordinate. That's over 4 and up 0. So that's 4, 0. Y-intercept is where the line crosses the y-axis. X-intercept, it crosses the x-axis. Now we're going to graph vertical and horizontal lines. Very important, follow very carefully. If I want to graph x equals -3, let me show you right now. I'd like you to follow me. X equals -3. There's the x-axis, there's the y-axis. X equals -3. So I go 1, 2, 3. X equals -3. What I just did was wrong, is incorrect. X equals -3 is not a singular point. X equals -3 is a line. Another way to think of it is, write this down. X equals -3 is all the points where x is -3. The best way to graph this is simply graph a bunch of points where x is -3. So my first one, that's -3, 0. And then I graph -3, +1, -3, +2, -3, +3, -3, +4. Do you see what's going on? All the points where. So x equals -3 is not a point. It's a vertical line where x equals -3. X equals 5 is all the points where x is 5. So you go to 5. That's 5, 0. 5, 1, 5, 2, 5, 3, 5, 4. And again, it's a vertical line. That's x equals 5. X equals 8, you go to 8. That is 8 here. That's 8, 0, 8, 1, 8, 2, 8, 3, 8, 4, 8, 5. And that is x equals +8. So I want you to do, I just demonstrated what all the x equals lines look like. You come over here to the U try. I want you to try to graph these 3 lines on your own. Pause the video, graph the lines, then restart. Pause the video. Let's see how you did. The line y equals -6 is going to be right here at -6, and it is a line. Y equals -6. Y equals 3 is right here. It's a horizontal line. It's all the points where y is 3 and y is 7. Is all the points where y is 7. So here's a quick summary. All the x equal lines are vertical. All the y equal lines are horizontal. Now, what if we're not dealing with vertical or horizontal lines? Then we're dealing with an equation of a line that has something called slope. The most common is the slope-intercept equation of a line. You guys know it as y equals mx plus b. That is the slope-intercept equation of a line. Y equals mx plus b. To graph, start by, you have an equation. Notice y is by itself. Always write the equation right underneath. Okay. Now let's identify our intercept first. So I'm going to circle the B and circle what's right above. Our y-intercept, which is b, -4. And then slope, circle what's right above it, just like I'm doing. Okay, so I'm going to start with my intercept at -4 on the y-axis, and that is because it is the y-intercept. Now, a lot of students get confused which way to tilt the line. That's why I taught you positive and negative. This is a positive slope. So automatically, I know my line has to tilt upwards from left to right. I'd like you to label your rise and your run. So from -4, my rise is 1. And then to keep it positive, I'm going to run 3. 1, 2, 3. Now I could also go down 1 and left 3. Now you have your points, and you simply always label your lines. This was y equals 1/3 x minus 4. We're going to do a couple more together and make sure you got the hang of this. Now notice our slope is a whole number. Whenever you have a whole number, automatically put it over 1. Never just write it as a whole number. Automatically put it over 1. Because remember, slope is rise over run. So you got to have that 1 there. So for this, your B is +3, so 3 on the y-axis. It is a negative slope, so I know my line has to go down from left to right. So my rise is 3. I can go up 3 and left 1. That would make a downward tilting line. Or I could drop 3 and go to the right 1. It's the same line. And again, label your lines. Y equals. Let's try another one. Now for this one, you start with the equation. Our slope, let's circle it. Our slope is 5/3, and then you go like this, and you're like, there's nothing there. So when there's nothing there, it is 0. So for this line, our intercept is actually 0. So we start at 0. It's a positive line, so I know it goes up from left to right. rise over run. So my rise is 5. Run 3, or I could drop 5. Run 3. Straight edge. That is y equals 5/3 x. Technically plus 0, but you don't have to write that down. Okay, I've given you 3 examples. This page, you're going to do on your own. So pause the video, restart when you're done. Alrighty, let's check. Your intercept was 5. Your slope was -3 over 2. So some of you might have went up 3. That's perfectly fine, but you kind of go off the graph. So I'm going to drop 3. And I'm going to go to the right 2 so I get a downward sloping line. How do I know it's downward sloping? Because it's negative. That was y equals -3 over 2x plus 5. Your slope here is 9 over 1. It was positive, so you go up 9. And I want it to right tilting because it's positive. Okay, make sure you correct your work. Make notes in red pen what you got right and what you need to watch out for next time. Okay, that's y equals mx plus b. Now, what I want to give you a demonstration is how is this actually used in real life? Okay, so you have 2 variables in an xy graph. You have an x and a y. Usually on the x-axis in statistics, that is called the independent variable, so we call it x. And the effect is the dependent variable, and we usually put the dependent along the y-axis. This is the same for reading graphs in science as well. Okay, what this means is independent and dependent. Think cause and effect. We had a lesson about cause and effect. Okay, x would be considered the cause, and y would be the effect. Y changes depending on x. That's why it's called the dependent. Okay, here's a real life example. A certain bank account promises a 25% simple interest on the original investment increased every year with an initial investment of $4,000. How much money will be in the account in 28 years? Okay, so think cause and effect. First off, 25%, keep in mind there's a couple ways to express that. 25% is the same as 0.25, like a quarter, and it's also 1 over 4. Okay, so in the 0 year, you have an initial investment of $4,000. After 1 year, you calculate 25% of 4,000. So 4,000 times 0.25, and that's going to be additional $1,000. So after 1 year, we're going to have ourselves $5,000. And after 3 years, when we say simple interest, it's always on the original, okay? It's after 2 years. So what I want you to show before we do these guys, I'm going to show you how to graph the line because we're going to be predicting these using an equation. So our equation here is this. Okay, right down here we're going to do our equation. Our equation is y equals, our change of rate is 1/4 x plus $4,000. All right? So let's graph this and then we'll check our predictions by our graph. So in year 0, let me take this graph away so it's easy to see. In year 0, $4,000. So this is by 1,000, so it starts right there. Then we go like this. We're going to go up 1. And then over 4, 1, 2, 3, 4. There's our second data point. Up 1, over 4. All right, and then let's do another data point. I can go like this. Up 1 again, and over 4. 1, 2, 3, 4. You get another point. You can see it's a very shallow slope. So very carefully, let's connect that. I'm going to bring it really close so it's easy to see. So we're starting at 4,000. All right. So we're going to go like this, and we're going to draw our line. So taking a look here at year number year number 1, it's 5,000. So what you do for the other years is you take this line and you simply predict, using the line graph, where we're going to be at 10 years. If you had a 100% accurate graph, you would go like this at 10 years, and then you would backtrack it this way. What would the amount of dollars be? Now this graph, because it's done by hand, is not terribly accurate. If you was computer generated, it'd be a lot easier. So that is a practical application of graphing of lines. It's used often for predictive nature items as well as in science. Main thing I want you to take away from this is the fact that okay, first off, let's come back here. You can see it here. We start with 4,000. And 4,000 times 25%. So 10% would be 400. And another 400. And then 5% would be 200. So that would be 5,000. That's where we got after 1 year. Okay, which if you look at the graph at 1 year, it's right there, which is true. So main thing you need to remember is the X is the independent and Y is the dependent.